Welcome once again, and today we are going to look at a tutorial still in physics, forces and Newton laws of motion. But today we are going to focus on a tutorial based on an object which is thrown upward. So the question reads, suppose that a ball is thrown upward at a speed of 15 meters per second by a person standing on the edge of a cliff so that the ball can fall to the base of the cliff 50 meters below. How long does it take the ball to reach the base of the cliff? And what is the total distance covered by the ball? So now the first thing that you need to write is the data that you have. And in this case, the data that you have is, you're going to write data. The data that we have, one is the initial velocity. The initial velocity given to be 15 meters per second. And the distance traveled is given to be minus 50 meters. So that distance is the distance between the edge of the cliff until the base of the cliff. This one is not the distance traveled by the ball. Okay, nope. It's the distance between this edge here, the top of the cliff, until the base of the cliff. However, when the person threw up the ball traveled from this distance from the top of the cliff to a maximum height, this point, and then came back to the edge of the cliff and then proceeded down to the base of the cliff. Now, another thing that we are also not given, but it is given somehow, is the acceleration, and in this case it is minus 9.8. And why are we saying the acceleration is minus 9.8? Remember, the acceleration in this case is the ball is accelerating going upwards. So when the upward acceleration is taken to be positive, then it means that we are going to have minus acceleration due to gravity, or minus g. However, if the downward acceleration is taken as positive acceleration, then acceleration is going to be g. So it's going to be 9.8 instead of minus 10.8. But in our example, we are using minus 9.8 because our acceleration is in the upward position, and therefore it is going against the acceleration due to gravity. So then, of the equations, kinetic equations that you can use to calculate the time, because we told how long does it take the time for the ball to reach the base of the cliff? How long does it take the time to travel from the roof of the cliff to the maximum height and back here until it reaches down? All right. So we can then say that the kinetic equations that you can use is the equation of distance, which says, or equation of the displacement, distance, or height, which says height, y, is equal to v, initial velocity, times time, plus half acceleration times time squared. And we are provided with the height, or the distance, which is minus 50, is equal to initial velocity is 15, so it's 15 meters per second, times time, so we're going to write t, plus half at squared, half, but t here is, a is minus, so we'll put in bracket minus 9.8 times t squared. So this one is going to give us minus 50 on the left hand side is equal to 15t. So plus times minus is going to give us minus 4.9t squared. So if you look at this equation, it looks like a quadratic equation, which in this case, because of t, okay, we can start by saying ax squared plus bx plus c is equal to 0. So in this case, we don't have x's, and we can write t. So you can say at squared plus bt plus c is equal to 0. Okay, and therefore we can say then we can rearrange this so that it can match this equation. So we have minus 4 4.9t squared. When it crosses the equal sign, is going to be positive. So you're going to have positive 4.9t squared. We have positive 15t. When it crosses the other side, is going to be minus 15t. And we have minus 50 is equal to 0. So once we have this, we can proceed and then say, remember from this equation here, we can now write it in form of t and say t is equal to minus b plus or minus b squared minus 4ac, and this one is under the square root and everything under 2a. So we are using this because we have two unknowns here. We have t, which is unknown, and also t here, which is unknown. And that's why once you have arrived at this equation here, then the only equation that you can use now here to help us find the value of t is the quadratic equation. So now let's proceed and put the values. So we have minus, so we can proceed and say t is equal to minus b, and our minus b here is minus 15. So minus times minus is going to be positive, and we will write 15. So we're going to say 15 plus or minus, we have b squared, and our b is minus 15. So we're going to write minus 15 squared. Let me just put everything under square root. Minus 15 squared, okay, minus 4 times minus our 4a, and our a is 4.9t. So we're going to just write times 4.9, that is our a, and our c times minus 50. Everything under 2a, and our a is 4.9. So if you look carefully, from here we can proceed and determine the value of our t. So we can then say that our t, okay, let me write here, t is equal to 15 plus or minus, so 15 squared, so we have 15 squared will be 225. So we're going to put under root, so 225. So if you take 4 times 4.9 times 50 is going to give us 980. So plus 980, everything divided by 2 times 4.9, that is going to give us 9.8. And we can proceed and say this is 15 plus or minus. So we have square root of 225 plus 980, and that's going to give us 34.7. So everything under the root is going to give us 34 point. Now let me go step by step so that you may not feel left behind. So now we are going to say this is equal to 225 plus 9. So we have 225 plus 980. That's going to give us 1250, 1205, everything over 9.8. And let me check the space. We're going to go up here and delete a little bit so that we can have more space, and calculate this thing, so that we want to know how long did it take this ball to reach at the base of the cliff. Remember, this ball was thrown upward. It went upward until it reaches a maximum height, and then it decided that, you know what, I want to go back. And once reaching back, I want to go until the edge of the cliff, the base down there. So we have said our t will proceed, and then we can then proceed and say our t is equal to 15 plus or minus square root of 1205 is 34.71, everything divided by 9.8. And we can say that our t is equal to 15 plus, if we take the plus, 34.71 over 9.8, or our t can be 15 minus 34.71 over 9.8. So 15 plus 34.71. So 15 plus 34.71 give us 49.7. So here we have 49.7 divided by 9.8. And this one is going to give us a value of 5.07. This one going to give us a value of 5.07, while this one, so we have 15 minus 34.71 divided by 9.8, and that's going to give us minus 2.01, and this gives us minus 2.01 seconds, and this seconds. So you can see that we are finding, once we solve the value of t, we get two values, but one is positive and one is negative. Okay, time cannot be negative. All right, so time is positive, and so we're going to choose the positive one, which is 5.07 seconds. So it means that it took this ball to travel from this point until it reaches a maximum height, and then went down until the base of the cliff. It took the ball 5.07 seconds. So once we apply that, then we can proceed and calculate part B, and the part B says what is the total distance traveled by the ball. So now the total distance traveled by the ball is the distance between the edge of the cliff where the person was standing until it threw it up. It reaches here, the maximum height, and the ball traveled back until it reaches this point where it started, and then we were told from this point until the base of the cliff is 50 meters. Okay, so then to get the total distance, we're just going to look the distance between this point until it went up. We can multiply by 2 because it came back again. Then that distance we are going to add to this 50 so that we can know the total distance that the ball traveled. And let's proceed and calculate that. So we can create space for that. We can create space for that. So let's create space for that so that we can proceed and calculate the height, the distance that it traveled all along. So now, yes, the distance that it traveled, we can use, remember, we only want to, first, our aim is to determine the distance it moved from here until its maximum height. Remember, it started from V naught here to V final on the top. And our V final on the top is 0. So we can then say that our final velocity, okay, final velocity squared is equal to initial velocity squared plus 2 times a change in y. Okay, and this is to remove or to remain with 2a dy. We can say v squared final in the y minus v naught squared is equal to 2a delta y. To get now delta y, we can divide both sides by 2a. We can divide this set by 2a, and this cancel. So we can then substitute and say, remember it reaches a maximum which was 0. So that is 0 squared minus 15 squared, okay, over times minus 9.8. And that's going to give us, so we have 0 squared, okay. 0 squared is 0. So we're going to have 0 minus 225 over minus 19.6. So that's going to give us minus 225 minus 225 divided by minus 19.6. And that's going to give us, because if you check, minus is going to cancel a minus, and you are going to have 225 divided by 19.6, and that is 11.48 meters. Okay, so it shows that this ball traveled from the top of the cliff to a maximum height covering a distance of 11.48 meters, 11.48 meters, and we're told to determine the total distance traveled by the ball. So you can see that from this point until this point is 11.48 meters, and from this point to back to the top of the cliff is also 11.48 meters. And from the top of the cliff downward, this one we've been told is 50 meters. Then we can say that the total distance traveled by the ball will be 11.48 plus 11.48 plus 50, everything in meters, okay? And that's gonna give us times 2 plus 50, and that's gonna give us 72.95. That's gonna give us 72.95 meters, approximately, can say 73 meters. So this is the total distance that the ball traveled from point A to, if we can say this is our point A, for instance, to point B and to point C at the edge, at the base of the cliff. So that's how you can approach this question and answer it. The most important thing to understand and to know is your acceleration, all right? Your acceleration. Is it positive or negative? Remember we said when you throw something upward, it is in the upward direction is taken to be positive acceleration, and therefore is going against acceleration due to gravity, and then that acceleration is going to be minus 9.8. Are we together? It's like you kick a ball up. When you kick the ball, it starts going up so fast, but then it reaches a point whereby due to gravity is pushing it back, it will start to fall again. And if it happens that downward motion is taken to be positive, then our acceleration is the same as acceleration due to gravity, and it will be 9.8 positive. Okay, so that's one of the things that you must understand. Another key point to understand and to note is to use the 4 kinetic equations. Which one do you need to use? The one that you need to use depends on the equations or the data that you are given and what you are looking for. Okay, and what you are looking for. Okay, so that's mark the end of this question, and we are going to proceeding with this question, saying a stone is thrown vertically upward with a speed of 24.0 meters per second. First question, how fast is it moving when it reaches a height of 13.0 meters? B, how much time is required to reach this height? C, why are there two answers to B? So let's just give an illustration. So assume that this is the point where the ball starts and the ball is thrown upward until it reaches a maximum height. And we're told that this height, the maximum height it reaches, so from that point to this point, is equal to 13 meters. And we're told the initial velocity that it was moving with is 24 meters per second. And it reaches a maximum velocity that we don't know. So we can say Vf is equal to unknown. But then acceleration again is 9.8, but is minus 9.8 because we take upward acceleration as positive, and therefore G is going to be negative because it's going against the acceleration due to gravity. So let's write these kinetic equations. We can say Vf is equal to V naught plus AT. Let's call this our first equation. And we can say Y, which is the height, is equal to, or the distance is equal to V naught T plus half AT squared. Let's call this equation 2. And equation 3, you can say final velocity squared is equal to initial velocity squared plus 2 times acceleration times change in displacement or distance. Now let's call this equation 3. What we are looking for final velocity for part A. How fast is it moving when it reaches a height of 13.0 meters? So we are looking at the final velocity. We cannot use equation 1 because despite having initial velocity and acceleration, we don't have time, and therefore we cannot have two unknowns in this case, and equation 1 is odd. We cannot use it. If you look equation 2, we have the height or the distance, we have initial velocity, we don't have time, we have acceleration, and therefore equation 2, we cannot use it still. Let's look equation 3. We have final velocity. Sorry, we are looking for the final velocity. We have initial velocity, we have acceleration, and we have distance. So we can get final velocity. And therefore, we are going to use equation 3. And we can say our final velocity is going to be initial velocity, which is 24 meters per second squared, okay, plus 2 times minus 9.8 times change, which is 13 meters. So our Vf, okay, is equal to 24 squared. 24 squared is 576. It's going to give us 576 plus 2 times, so we have 2 times 9.8, but it's minus times 13. So that's going to give us 254. So we're going to say plus in bracket minus 254.8, and we're going to put like this, and this is going to give us 576 minus 254.8, and that is going to give us a value of 576 minus answer. It's going to give us 321.2. So we can then say that Vf squared is equal to 321.2. And now to get V, we are going to say the square root of 321.2, and that one will give us square root of answer, will give us 17.9. Will give us a value of 17.92 meters per second. So this is the value of the final velocity that this stone attained or had when it reached at this maximum point. So we are told how much time is required to reach the height. So we have this value here, 13. We have initial velocity. So we have distance, we have final initial velocity. Sorry, we don't have time. So we can use this equation 2 so that we can find time. And in this case, 13. So we're going to say 13 is equal to initial velocity is 24. So we have 24, but it is t plus half times acceleration, which is minus 9.8 times t squared. So this is going to give us 13 is equal to 24 t minus, because it's a positive times a negative is a negative. 2 goes here, 1, 2 goes here, 4.9. So it's going to give us minus 4.9 t squared. We can rearrange this. We can write this in form of quadratic equation, and then we can say it is at squared plus bt plus c is equal to 0. And once we have written it like this, we can rearrange our equation. I'll call it equation 4. Now we can rearrange our equation 4 by saying we have 4.9 t squared, because this is minus 4. When it crosses the equal sign, it becomes positive, and this is minus 24t. It is minus 24t because if it crosses the other side, it's going to be minus, and then we say plus 13 is equal to 0. So we can proceed here and write and proceed. Okay, we still have space. Bingo. So from here, we can say that our t is equal to minus b plus or minus the square root of b squared minus 4ac. And this can proceed and say minus b, our b is minus 24. So minus 24 times minus is going to give us positive, and that is positive 24 plus minus everything under root. So b squared is minus 24. So we're going to say minus 24 squared, okay, minus 4 times a, and our a is 4.9 times c, and our c is 13. Okay, everything under 2.2 times a, and our a is 4.9. So we can proceed here. We can proceed from there. We can proceed and say our t, let me minimize this a little bit so that you see it. Okay, we can then proceed and say our t okay, we can then proceed and say our t is equal to 24 plus or minus, okay, now 24 squared minus 24 squared minus 24 squared is going to give us 576. 576, and we have minus 154.8, and everything under 9.8, because 2 times 4.9 is 9.8, and that's going to give us the value of t to be 24 plus or minus 321.2 over 9.8, and that's going to give us 24 plus or minus square root of 321. Square root of 321 is going to give us 17.9, 17.92, and divide by 9.8, and that's going to give us t to be either to be 4.2, 4.2 seconds, or t, so you can call this t1 and this our t2. We can say it is, so we subtract in this case and say 24 minus 17.92 divided by 9.8, and that's give us 0.62. So we get 0.62. Okay, 0.62 second. This 2 times corresponds to the times in which the ball was moving upwards and downwards. So T2, which is 0.62 seconds, corresponds to the time the ball was moving upward. Remember, the ball was moving until it reaches a speed or a point whereby as it continues going up, the force of gravity or acceleration due to gravity is decreasing its speed. You throw it up, it moves up so quick, but as it continues going up, g decreases its speed. But 4.2 seconds is the time when the ball is coming down. So when the ball is coming down, it is being supported by g, so the g is increasing its speed. So that's the difference between these 2 seconds or 2 times. 4.2 when the ball is moving downwards, and 0.62 is when the ball is moving upward. When it moves upward, its speed is being decreased by g, but when it's moving downwards, its speed is being increased by g. The question part C says, why are to be? And we have seen the 2 answers to be. There's this one and there's this one. There are 2 answers to be because when the ball is going upward or when the ball is moving upward, it reaches a point whereby it passes the maximum height 13, and when it passes that height, its speed is being decreased by g. While when the ball is moving down, its speed is being increased by g. So that's the reason why we are having 2 answers. Hope you followed, and I can say see you next time. Hey, remember to subscribe, hit the notification bell, so each and every time we make new uploads, you can be notified, and then you come and increase knowledge. We are here to solve your academic problems by giving you the solutions. Thank you. Bye-bye. Adios.